Now that we have defined uncertainty as that which is unknowable and unable to predict, despite the strategically relevant information we have, we want to now focus on some of the tools that managers can use. One of these tools is game theory. Game theory is a way to model strategic interactions and behavior between competitors. So in terms of the sources of uncertainty, game theory is very useful when thinking about uncertainty around competition. There are several key components of games. One are the players, or the rivals, the competitors. Two is the strategic choice of action that we're focusing on, or the decision. And then three are the outcomes or the payoffs. What's important to note about games is these are not pure chance. Game theory comes from economics, and there is a sophisticated series of math equations behind each of the games. Now, within game theory, a strategy is a decision rule or a plan of action that the firm may take when facing a decision. However, this strategy may be dependent or contingent upon other players' actions. And so different types of games will model out different types of scenarios or different types of situations where maybe both rivals or both players move at once, or one moves first and the other follows. There are several key assumptions involved in game theory. For example, payoffs are known and fixed. So this assumes that the players, the firms, know what the options are and they're fixed. Two, players behave rationally. Now this is important. By rationally, we mean they will maximize their payoff. This may not always be the case in some situations, but still in game theory we must make this assumption of rationality. We can then later think about what happens if they behave irrationally. And then three, the rules of the game are common knowledge. In other words, the choices of action and the outcomes and payoffs are known to all firms. The objective in game theory is to analyze the interaction of players in the game and come up or define what the equilibrium outcome will be. In other words, if each actor or each player plays the best response to the strategy of the other players, we should arrive at some outcome that is the equilibrium, that is the likely outcome that we can focus on. At this point, or at this likely outcome, there is no incentive to change strategy. Now it's important to note this is not necessarily the best possible outcome for all firms, but it's the most likely outcome. And so, for example, in the some of the common games, we can identify one or two situations of the likely outcomes. Now there are various types of games. First of all, there are zero-sum games. In a zero-sum game, someone wins, but if someone wins, someone has to lose. And typically in game theory, we try to model the game with a limited number of players to be able to make the math work and define the equilibrium outcome. And this involves making simplified assumptions where we may, instead of having 10 firms, we may put 2 or 3 firms to represent various types of firms that exist. The other type of game is a non-zero-sum game where both firms can win. And in this situation, you might have a situation where the two firms can work together in collaboration. And then we have the timing of the game. The simultaneous game is when both firms or both players move at the same time without prior knowledge or without knowledge of the other player's action. Versus a sequential game where one player sees what the other player does first and then makes his or her decision. And then finally, how many interactions are there? Is it a one-time game where we interact once, or is it a repeated game? Now, using game theory in business or in strategy, we're most likely looking at repeated games where we're going to keep facing this competition over and over unless there's an unusual situation. The most common type of game that most people understand or have seen before is the prisoner's dilemma, where we have two players. Each player is being questioned by detectives for a robbery, and the detectives are questioning each player separately without communication. There, what the detectives are trying to do is figure out who's responsible for the robbery, knowing that one of the players, at least one of them, if not both, conducted the robbery. And the goal is to figure out which one. And the question becomes, what are the likely moves of each of the two defendants here? And the payoffs for the defendants depend on the actions of each player. And the typical outcome of the prisoner's dilemma is both players or both of the accused robbers know the other one might confess and blame each other, and as a result, they both end up in jail. So again, by looking at the actor and the best response to strategies, we can often see what the likely outcome is. And the Prisoner's Dilemma is a very common game which you can view online. There are lots of videos about it. We now want to think about how we might use game theory in strategic planning or in strategic decision making. Again, as noted in the first video, most strategic decisions involve dealing with the likely moves of competitors either before or after your own decision. So you're either anticipating a competitor move, or you're trying to anticipate how a competitor will react once you make a decision. Game theory provides us a structured process to look at this uncertainty. We want to look forward to what potential actions might be and reason our way backward to figure out what we should do today. We don't necessarily have to solve the game. That is helpful if we can actually solve the game and figure out what our payoff will be by using some of the mathematical equations. But even without formally solving the mathematical equations, we can still generate insights during the process to better understand what our likely competitor moves will be, and therefore what our likely move, our own move, should be. And when we start to think about using game theory in this context, we have to first define the strategic issue or problem and determine the relevant players. After we've determined the relevant players, we then have to identify those players' specific objectives. And this is where the issue of rationality comes in, because sometimes the players' objectives may not be pure maximization of payoff. Once we've identified the players and their objectives, we then want to think about what actions might each player have from their own perspective. And this involves getting into their viewpoint and walking in their shoes, so to speak, to identify what they might do. This will then help us determine the likely structure of the game and the potential payoffs. During this process, some of the key questions we want to think about as we model this game are, first of all, will the competitor react at all? Sometimes competitors may not react because we may not be attacking a core market, or they may not have the resources to react. Second, if the competitor is going to react, which options will they likely consider most probable? And here we're focusing on things that maybe they've done in the past, or we know they tend to focus on certain types of markets. And then finally, this information helps us decide which option will the competitor most likely choose. So when we apply game theory to strategy, some of the core assumptions that pure economic game theory uses, we may have to adapt. But again, the goal here is not necessarily just to solve the game, but to generate insights that will help us resolve some of this uncertainty and help us make a better strategic decision.